So again, for today, this is big data. This is under week 6. So the contents of this week. So our learning objectives for today is to define the big data, discuss the key enablers of big data, categories of big data, sources of big data, types of data, so the 3 Bs and the other Vs. So we are going to discuss what is big data, how is it different from small data, and how will it impact our lives. So is big data a good thing? So now, let's try to define what is a big data. So this is a massive set of unstructured, semi-structured data from web traffic, social media, and sensors. So as we all know, we have petabytes and exabytes of data. So this kind of volume of data is too big for a typical database management system. That's why handling big data is crucial and critical for some companies, okay? So the information from multiple internal and external sources like transactions, social media, enterprise content, sensors, and mobile devices. In the last minute, so for example, we're going to have 204 million emails sent. That is considered as a big data. We have 61,000 hours of music, okay? 20 million photo views, 100,000 tweets, 6 million views, and 277,000 Facebook logins, to 2 million plus Google search, and 3 million uploads on Flickr. So imagine that kind of data. In just a minute, we're going to generate that kind of data. Okay, so companies leverage data to adopt products and services. That is for meeting the customer needs, optimize the operations, optimize infrastructure, find new sources of revenue, can reveal more patterns and anomalies. Okay, so IBM estimates that by 2015, 4.4 million jobs will be created globally to support the big data. So 1.9 million of these jobs will be in the United States. So what are the key enablers of big data? We have the data storage, we have the processing capacity, and we have the data availability. When you say data storage, this is the process of recording information. When we say processing capacity, this is how many operations a processor can perform in a given amount of time. So we're talking about speed here, okay? And then data availability. So making data accessible to users and application whenever it is needed, okay? So again, storage is recording or saving. Processing capacity, we're talking about speed here, and the data availability, we're talking about accessibility. Okay? So now let's try to discuss the categories of big data. So we have the first one, which is the structured data. When you say structured data, it has metadata and a fixed length and format. Like for example, the name, the dates, the addresses, and the phone number. So metadata is a data that provides information than other data, and it is about data. So for example, creating an account, okay? That is a metadata wherein you have to put your name, okay? You have to put your first name, your last name. You can put your email address, your password, and then your birthday, and also your gender. This one is called the structured data. So what next is, the second one is unstructured data. So what is unstructured data? When you say unstructured, this is not organized, okay? which is hard to recognize. Okay, so it does not have any metadata, and this is 80% of all data. So for example, as shown on the screen, the sentence inside the box is an unstructured data. So for example, my name is Jerry Allen. My friend called me Jerry. I am 17 years old. I am male. I was born in August 4, 2000. My email address is jerry.allen@email.com. I won't tell you my password because that's private. So this one is unstructured because it is unorganized. Okay? So the third one is semi-structured data. So this is a cross between structured and unstructured data. So meaning to say it's mixed. So it is not completely organized, but it has some recognizable parts. So for example, as shown on the right side of your screen, okay? So as you can see here, we have a format for the date. We have the format for the email address, and then they are using also hashtag. I think we are all familiar with the hashtag. We're using hashtag for what? For the Facebook, for Twitter, okay? We are using hashtag. This is a metadata tag that is used to identify message that is related to a specific topic. So more on like filtering your messages, okay? That you can filter because there is a specific topic about that hashtag. Okay? So this is semi-structured data. Now, where does the big data come from? It can came from the enterprise or the dark data. It can came from the partner, employee, customer, supplier. It can came from public, commercial, and social media. So these are the possible sources of the big data. Okay. So let's talk about specifically the sources of big data. First is the social data. So of course, the social data came from the people online social interactions. Okay, so meaning to say social media. The most common example of this is social media, status updates, preferences, photos, videos. Okay, 300 million photos are uploaded every day on Facebook. So meaning to say like the photos that you uploaded in the Facebook, your timeline, that is social data. Okay. The next one is transactional data. When we say transactional data, this is the digital record of business transaction. Okay? So companies have to keep records of all their transaction, analyze to gain valuable business information, and by 2020, 450 billion business transactions created in the internet per day. So when you say transactional data or the digital records, it could be the possible data here is like what? Reservations, payments, okay, through online. So next is the machine data. So when you say machine data, this is created by computers and smart objects. So the machine data are transmitted through the wireless network and kept in servers. Okay? So basically, as we all know, if we're talking about the machine data, like for example, I have my computer at home, okay? And then I am trying to connect in a certain server. So the data that will be what that will came from my computer and will be fetched by the server is a machine data, a data that can only be understood by the server and its client. Okay. So let's talk about now about the types of data. There are different types of data. So there are, when collecting or gathering data, we collect data from individual cases on particular variables. So a variable is a unit of data collection whose value can vary. So variables can be defined into types according to the level of mathematical scaling and then can be carried out on a data. So there are four types of data or levels of measurement. So again, The four levels of measurement, we have four here as shown on the screen. It's categorical or nominal. We also have the ordinal, we have the interval, we have the ratio. So again, these are the four levels of measurements. Now let's discuss one by one what is categorical or nominal, what is ordinal, what is interval, and what is ratio. So when we say categorical or nominal data, so these are the data that comprise the categories that cannot be ranked or ordered. Okay? So it cannot be placed in any order. No judgment can be made about the relative size or distance from one category to another. So it bears no quantitative relationship to one another. So for example, customer's location, employee classification. Okay, so again, these are no mathematical operations that can be performed on the data relative to each other. That's why this is called as nominal, because this is what? Qualitative differences. It's not quantitative. Okay, so as you can see here, for example, nominal data, what is your gender? Okay, male or female? Did you enjoy the film? Yes or no? That is a nominal data. So to measure the nominal data, you have to ensure that each category is mutually exclusive. And the system of measurement needs to be exhaustive. So when we say exhaustive, okay, the system of category system should have enough categories for all of the observations. So when you say the answer can only be yes or no, it is known as the dichotomies. Okay? So try to remember that about nominal data. So the second one is the ordinal data. When we say ordinal, okay, this is that's why it's called ordinal. It can be ranked, ordered, or in order, in a certain order. So for example, okay, this is a sample survey as you can see on the screen. How satisfied are you with the level of service you have received? Very satisfied, somewhat satisfied, neutral, somewhat dissatisfied, very dissatisfied. Okay, so again, when we say ordinal, it is based in a rank order. Okay, similar with the nominal data, the distance between each category cannot be calculated, but it can be ranked above or below. Okay, so there is no fixed units of measurements here because this is ordinal. This is only for ranking. So for example, college football rankings, survey responses, like for example, the very satisfied, somewhat satisfied, neutral, somewhat dissatisfied, very satisfied, or poor, average, good, very good, or excellent. So with the use of the ordinal data, it can make statistical judgments and perform limited maths. Okay? So this is ordinal data. The next one is the interval and the ratio data. So when you say interval and ratio data, these are examples of the scale data. So for example, what are the scale data? Numeric formats, okay? $50, $100, $150. It can be measured also in a continuous scale. You can measure also the distance, okay? And then it can place in rank order also. So this is interval and ratio data. So interval, for example, okay, time, okay, it moves along a continuous measure or seconds, minutes, and so on, and is without 0 point of time. Temperature, okay, and then scores. So that is interval. Next is ratio. So when you say ratio data, it is a continuous scale and does have a natural 0 point. So again, interval data does not have any 0 point. while the ratio data, it does have a natural 0 point, okay? Like for example, the monthly sales, the delivery times, the weight, the height, and the age. So continuous because, for example, monthly sales can change. For example, my sales this month will can change in the next month. Okay, even my weight. If my weight right now is 50 kilograms, what will my weight may change after a month. Okay, same with the age. So, this year, this is my age, and then next year, of course, it will add up. So again, that is ratio data. So data for business analytics, so classifying data elements in a purchasing database. So for example, this is my database. I have this table as shown on the screen. The name of the table is purchase orders, wherein I have different fields. Okay, I have the field of the supplier, the order number, the item number, item description, item cost, quantity, cost per order, AP terms. Okay, months, and then order date, and then arrival date. Now, the supplier, the order number, the item description are called the categorical or the nominal data. So again, they are qualitative data. While the ratio and the item cost, the quantity, the cost per order, and the AP terms, okay, per month is ratio. While the order date, the arrival date, that is called as the interval data. So that is an example of classification of your data. Okay? So if there was a column for supply and rating like excellent, good, acceptable, bad, so that would be the ordinal, if ever. So now, after classifying the types of data, the levels of measurement, let's move on to the big data characteristics, which is the 3Vs. Okay? So, according to Gartner, February 2001, so the big data characteristics is volume, variety, and then velocity. Okay? So, this is the big 3Vs. Okay? So the big data characteristics discusses the growing quantity of data, like for example, in the social media, behavioral, and the video. It quickens the speed of data, like the smart meters, process monitoring, and it increase in types of data. So I think we discussed this from the first slide, like the structured, if you remember, the unstructured, the semi-structured. So this is the big data characteristics. So which big data characteristic is the biggest issue for your organization? So this is based from Gartner. So based on the chart on your screen, okay, the biggest issue is the variety of data, which has 48%, while the followed by the volume of data, which falls on 35%, and the velocity of data that falls into 16%. So let's try to discuss one by one the big three V's. Okay, what's different about big data? Volume, velocity, variety. So when you say volume, it is about massive data sets. Okay. So for example, volume scale of data. So we're talking about petabytes. We're talking about exabytes of data. So again, this kind of data is too big for a typical database management system. So for example, imagine 40 zettabytes or 43 trillion gigabytes data will be created by 2020, an increase of 300 times from 2005, because there are 6 billion people who have cell phones. Okay, according to the latest searching Okay, like the world population is around 7 billion. It's estimated that 2.5 quintillion bytes of data are created each day. So most companies in the US have at least 100 terabytes or 100,000 gigabyte of data store. Okay? So if we're talking about the volume, we're talking about the scale of data or the volumes that is too big for handling. Okay? Okay, volume bytes defined. So for example, 1 terabyte. Okay? So it's 1 trillion bytes. Do you know how big a 1 terabyte is, class? It can handle, like for example, 500 hours of movies. We're talking about HD movies. So that's how big a 1 terabyte is. Okay? So it's like it can handle 250,000 movies. Okay? Imagine that. We're not talking about the petabyte or the exabyte yet. It's just 1 terabyte. So 1 petabyte, 1 quadrillion bytes. So eBay warehouse, okay, data warehouse that on 2010, it handles 10 petabyte. eBay will increase 2.5 times by 2011. So Teradata is greater than the 10 petabyte. So let's try to discuss the equivalence of each byte. Okay. So let's try to discuss the scale of data, okay, in the volume. So when you say bit, okay, 0 or 1, so it's 1/8 of a byte. When we say byte, it's 8 bits, which is equals to 1 byte. Kilobyte, that's 1,000 bytes. Megabyte, that is, okay, 1 million bytes. Gigabyte, 1 billion, okay? So we also have the terabyte, 1 trillion, so on and so forth, okay? So we have the petabyte here, we have the exabyte here, we have the zettabyte, and we have the yottabyte. So as of this moment, as far as I know, for the flash drives, we are using the gigabyte. And then for the external hard disk, we are using terabytes, right? I think we have a 1 terabyte for the external. There's more than, of course. But for the companies, they are trying to use the petabyte, the exabyte because of the large or the big data. Okay? So 90% of today's data has been created in just the last 2 years. Every day, we create 2.5 quintillion bytes of data or enough to fill 10 million Blu-ray discs. So 40 zettabytes or 40 trillion gigabytes of data will be created by 2020. So an increase of 300 times from 2005. And the equivalent of 5,200 gigabytes of data for every man and woman and child on Earth. Okay? So most companies in the US have over 100 terabytes of data stored. So that is the volume. So next is velocity. When we say velocity, this is the information in real time. So for example, the New York Stock Exchange that captures 1 terabyte of trade information during each trading session. Okay? Modern cars that have close to 100 sensors, okay, that monitor items such as fuel level and tire pressure. So by 2016, it is projected there will be 18.9 billion network connections. Imagine that. So almost 2.5 connections per person on Earth. So when we say velocity, we're talking about the analysis of streaming data. This is massive amount of streaming. Okay, so analysis of streaming data, where do we use streaming? So as you can see on your screens, okay, we have the searching here, okay, we have checking the stock exchange, security cameras, okay. Next one is variety. When we say variety, this is the unstructured and unwieldy data. Okay? So when we're talking about variety, we're talking about the different forms of a data. So as of 2011, the global size of data in healthcare was estimated to be 150 exabytes or 161 billion gigabytes. Okay? 30 billion pieces of content are shared on Facebook every month. So we also have 400 million tweets. So sent per day by about 200 million monthly active users. There are 4 billion plus hours of video. So imagine those data. And then by 2014, it is anticipated that there will be 420 million wearable wireless health monitors. Like for example, the smartwatch, okay? So this is a massive set of unstructured, semi-structured data from web traffic, social media, and sensors. So again, this is variety. So again, the different forms of data or the variety came from this social media, like from LinkedIn, Facebook, Reddit, G Suite, the Flickr, the Twitter, the WhatsApp, the Spotify, the Messenger, okay, the YouTube. So these are the sources of the different forms of data. So 2016, what happens in an internet minute? So for example, Facebook, in just 1 minute, there are 701,389 Facebook logins. What about Netflix? There are 69,444 hours watched in just a minute. Okay? So next, 150 million emails sent. Uber, 1,389 rides. Photos shared, there are 527,760. So there is also 51,000 app downloads from Apple. Amazon has 203,596 sales. The LinkedIn account has 124 plus new accounts in just 1 minute. There are 347,222 new tweets in just 1 minute. There are 38,194 posts in Instagram in just 1 minute. Okay, there are 1.04 million Vine loops in just 1 minute. There are 38,052 hours of music in the Spotify. There are 2.4 million search queries in the Google. There are 972,222 swipes in Tinder in just 1 minute. And then there are 2.78 million video views in YouTube in just 1 minute. And there are 20.8 million plus messages in the WhatsApp. So imagine that data that has to be handled, okay? So this is based from Excel.com, okay, in 2016. So now, after discussing the three V's of the big data, there are also others, which is the veracity, the value, the variability, and the visualization. When you say veracity, this is the trustworthiness of a data. When we say value, the usefulness of a data. Variability, this is the constant change in the meaning of data. When we say visualization, this is condensing and converting data into understandable format. So we're going to discuss this one by one. So which source of data represents the most immediate opportunity? Okay. So from the dark data, okay, or existing underutilized, 38%. From customers, suppliers, 38%. Social media, okay, 16%. Commercially available data, 4%. And publicly available data, 4%. So again, This is from Gartner, May 2012. So big data opportunities. With the big data, okay, making better informed decisions, so strategies and recommendation because you have the data. Discovering hidden insights, like for example, anomalies, forensics, patterns, or trends. Like for example, I have a credit card, okay, and then my bank seen some anomalies on my purchase. Like for example, I live in Luzon and then I got a purchase in Mindanao. Is that possible? Especially if I'm not a buyer that buys in Mindanao. So they can discover that through the use of big data. They can say that your credit card is being hacked. Okay? That's the purpose of the big data also. They can help because of the patterns. Okay? Next, automating business processes, complex events, translation. Okay? So these are the big data opportunities. So which is the biggest opportunity for big data in your organization? So through 2017, 85% of Fortune 500 organizations will be unable to exploit big data for competitive advantage. Okay, so meaning to say security of data. So business analytics needs will drive 70% of investments in the expansion and modernization of information infrastructure. As we all know, there are data that are private, okay? They cannot just share your data. So they are using our data for competitive advantage. Like for example, I am using the data for my business, okay? Like I want to offer some promotions, I want to sell some products, okay? That is only for my company. But what about company B? So company B has to get their own data, enable for them to make some sales. So in here, it shows that the insight discovery has the biggest opportunity for the big data, which falls into 45%. So followed by decision making, which is 40%. And the last one is the process automation with 12%. Okay, next, business analytics. So we're going to use of course, the big data. So the business analytics or the business intelligence is a broad category of application, technologies, and process for gathering, storing, accessing, and analyzing data. This helps the business users to make better decisions. Okay? So many companies are performing new kinds of analytics to better and more quickly understand and respond to what customers are saying about them and their products. So they are using the cloud actually to use, it is being used for data storage. Okay? So next is the veracity, or also known as the uncertainty of data. So 1 in 3 business leaders, for example, don't trust the information they use to make decisions. So 27% of respondents in one survey were unsure of how much of their data was inaccurate. And then poor data quality costs the US economy around, so it's about 3.1 trillion a year. So again, if we're talking about the big data, so veracity, uncertainty of data. So this is about the trustworthiness of a data. So they are considering the origin, authenticity, trustworthiness, completeness, and integrity. Okay? Okay, next. So analytics model, we have the descriptive analytics, diagnostic analytics, predictive analytics, and the prescriptive analytics. So when you say prescriptive, what happened? Diagnostic, why did it happen? And then predictive, what will happen? And then prescriptive, how can we make it happen? So when you say descriptive analytics, we're talking about here about the reporting, okay? Dashboards, data visualization, okay? They are the core or of traditional business intelligence, okay? So descriptive analytics uses data visualization. This is important because it helps the users interpret the output of predictive analytics. Okay? So when we say predictive analytics, this is the algorithm for predictive analytics such as regression analysis, machine learning, and neural networks. Okay? So this is just an example of prescriptive analytics, okay? Wherein we can use the optimization. This is optimization class, okay? So this is useful for, like for example, healthcare, okay? So healthcare strategic planning, because it can leverage the operational and usage data combined with data of external factors, okay, such as economic data, population, demographic trends, and population health trends. Like for example, for this date, our pandemic, okay, the COVID-19. Prescriptive analytics is useful as of this date. Okay, because that will be the basis, okay, that will be the basis. What would be the plan for the pandemic? What should be the capital investments? What are the facilities that is needed? What are the equipments needed? Okay, so this is prescriptive analytics. Organizational transformation. So analytics are a competitive requirement. So for business intelligence based organizations, the use of the business intelligence analytics is a requirement. Okay? So the big data analytics found that 85% of respondents indicated that their firms would be using advanced analytics within 3 years. Okay? So basically, if you are a company, it will help you more. Okay? It can help you more what you should do next, because it can help you decide what are the possible outcomes, what will happen. So complex system require analytics. It tackles complex problems and provide individualized solutions. Products and services are organized around the needs of individual customers. Dollar value of interactions with each customer is high. So there is a high level of interaction with each customer. So for example, we have the IBM, we have the World Bank, okay? So volume operations, it require analytics, okay? It serves high volume markets through standardized products and services. Each customer interaction has a low dollar value. So customer interactions are generally conducted through technology rather than person to person. So these are likely to be analytics based. So for example, we have the Amazon.com, we have the eBay, if you are familiar with this one. So they are commonly used in purchasing goods, right? The eBay, the Amazon. So nature of the industry. So online retailers like the Amazon.com and the Overstock.com are high volume operations who rely on analytics to compete. So meaning to say they are using the analytics. Okay? So when you enter their sites, a cookie is placed on your PC and all clicks are recorded. So meaning to say there are key logs. They are using your logs. Okay? So based on your clicks and any search term, recommendation engines decide what products to display. It helps them filtering your search, okay? After you purchase an item, they have additional information that is used in marketing campaigns. Customer segmentation analysis is used in deciding what promotions to send you. So of course, that will be based on what you click. Like for example, I click jewelry, then they will filter or they will send promotions that is about jewelry. Okay, that's how they filter your searching. So how profitable you are influences how the customer care center treats you. Next is a pricing team helps set prices and decides what prices are needed to clear out the merchandise. So next is forecasting models are used to decide how many items to order for inventory. So actually, the forecasting model is being used depends on the, for example, I have a product. Let's say I have an Apple phone. So it seems that based on my monthly sale, the Apple phone is the highest sale I have, okay, compared into the, let's say, Samsung. Then basically, I will buy what? I will store more Apple phones because based on the model, based on forecasting, this is the current trend right now. This is what the public is buying. So of course, I am to stock Apple phones. Okay? So dashboard monitor all aspects of organizational performance. So knowledge requirements for advanced analytics, you need the data, business domain, and the modeling. You have to choose the right data to include in the model. Okay, that is important. Next is the variables that might be related. Next, domain knowledge that is necessary to understand how can they be used. Okay. Next is visualization. Okay. So when you say visualization, this is the acquisition of insight. So many people and institutions possess data that may hide fundamental relations. Okay? So for example, realtors, bankers, air traffic controller, fraud investigators, and engineers. So fraud detection. So as I mentioned a while ago, the big data is also used for fraud detection. They can help that to determine the pattern. Okay? So for example here, the Serious Fraud Office or the SFO suspected mortgage fraud. The SFO provided 12 filing cabinets of data. After 12 years, a suspect was identified. The suspect was arrested, tried, and convicted. Okay, that's the use of the big data. The big data is not only for storage, not only for recording, but aside from that, it can be used for analysis. It can be used for pattern matching. Okay, so continuing the example a while ago, the data was supplied in electronic form. A visualization tool, which is the net map, was used to examine the data. After 4 person weeks, the same suspect was identified. A master criminal behind the fraud was also identified. Is information visualization useful? So of course, yes, because it can what? It can represent multiple sources of information, okay? It will vary depending on what do you need. Okay, it will help the people make the detection process easier. Okay? So for example, aside from that, epidemic, okay? With the use of the visualization, the cholera epidemic in London 1845 can map the deaths and noted the deaths indicated by points tended to occur near the broad strip map. So closure of the pump coincided with the reduction in cholera. So with the use of the visualization, they map out where is the source of this epidemic, and then after identifying the source, then they will lock it down. Okay? Challenger disaster. Another example. On 28 January 1986, the Space Shuttle Challengers exploded and 7 astronauts died because 2 rubber O-rings leaked. So the previous day, engineers who designed the rocket opposed the launch, concerned that the O-rings would not seal at the forecast temperature. After much discussion, the decision was taken to go ahead. Causes of the accident: an inability to assess the link between cold temperature and O-ring damage on earlier flights. So many charts poorly presented. So for example, this is the example of another visualization. So again, when you say visualization, it refers to the innovative use of images, interactive technology to explore large and high density data sets. Okay, it helps the users to see patterns, relationships. Okay, that is difficult to see on text. Okay, so these are, for example, rich graphs, charts, dashboards, and maps. Okay? So this is used to identify insights into both structured and unstructured data for such area like operational efficiency, profitability, and strategic planning. Okay? As you can see on the screen at the right side of your screen, sometimes it is hard to read these numbers. If you see these numbers, how am I going to check this one? So by the use of visualization, by the use of these charts, it is easy to visualize which one is better, which is the one that I got more sales. Okay? Another example like this one, the geodata mapping. Okay? You can easily identify through visualization. So for example, this is Latin America, this is Asia and America, based on the colors, based on the map. Okay? So for example, this one, okay? So you can easily identify the location and then the tree map based on the color and visualization. We also have the trendalizer or the population, wherein you can see which is a bigger population, which has a bigger income. You can see it through a trendalizer.